A potter's wheel, a thick stone disc of radius of half a meter and a mass of 110 kilograms, is freely rotating at 50 revolutions per minute. The potter can stop the wheel in 6 seconds by pressing a wet rag against the rim and exerting a radially inward force of 68 newtons. Find the effective coefficient of kinetic friction between the wheel and the rag. So here is our relevant diagram and picture. Let's just say force, and it's the normal force from the 68 newtons. We'll get there later. Okay, so we have the what's it called again? The wheel rotating at like counterclockwise, and since it's kinetic friction, it has to act in the opposite direction of the motion. So this is acting clockwise. So from that, we get our little torque equation. So we have the net torque is the negative torque from the friction is like some torque, which is just I alpha, which is like the MA. It's negative again because it's opposite. We're gonna call positive counterclockwise, and it has to be opposite. So from this, obviously, kinetic friction force is just mu k times the normal force, and then R because it's torque, and then half of mr squared because it is a, hold on, I gotta find out, it's a uniform solid cylinder. So that's the moment of inertia of a uniform solid cylinder times Miss alpha, and then we I got rid of the negative because coefficient of friction, it doesn't matter. If we were solving for, like, say, the force or like alpha, the negative does matter, but we just need the absolute value of the coefficient. It doesn't matter if it's negative or not. So then we just kind of move things around, just divide by these guys. One of the r's cancels out, and you get mr alpha over 2f. And before I can get to this step, I need to talk about how I went from revolutions per minute to radians per second squared, which is just alpha. So this took a couple steps. The only thing they gave us was that 50 revolutions per minute, which is right here, and I had to convert it to radians. So I wanted to do this question because I had to convert stuff like this. I would say it's like such a small thing, but every time I try to convert like meters, or like in this case revolutions, to radians, it just always trips me up. I always forget about the 2 pi stuff, and always just like messing me up. So this problem really did help me like figure out how to get from revolutions to radians, or like radians to revolutions if I need to. So it's, you got to get rid of the revolutions and you got to get to radians. You do that by multiplying by 2 pi. That's the thing that always trips me up, is the 2 pi, because I never know when to use it. And then minutes to seconds. And then this only gives us our velocity. So just like it's, acceleration is just velocity over time. So this is the velocity that we just found, and the 6 seconds is because the potter can stop the wheel in 6 seconds. So that's just like the duration, and you get 0.8727 radians per second squared, which is what I put over here, and I just forgot the unit. Oopsies. Oh, that's just RDD. Hold on. Radian per second. Okay. And then you do over, so it's like the mass, the given radius, the acceleration we found, 2. This is the normal force because this is the force from the guy, the radially inward force from the guy, and you get 0.353 for your coefficient of kinetic friction.